because this is simply a collection array. See, in Spark, to perform the grouping aggregation, suppose observe this one query, equivalent SQL query I am giving. Suppose I am saying that the query selects X comma sum of salary from table group by sex. When you submit this query, you are expecting grouping aggregations. But to do this kind of aggregations, you need to transform the data, because the Spark rule is to perform grouping aggregations, input should be a pair RDD. Here pair is a tuple. Tuple contains only two things here. One is key, second one is value. To achieve such kind of things, you need to transform the data like this. Suppose look at the first observation, first element. So here key is M, the value is 30,000. We need to make it as a tuple. Each element is a tuple, the sex as key, salary as value. For the second row, same sex is F and salary is 50,000. In this way, for each element, we need to extract key value pairs. Okay. So how to transform your text data into key value pairs? So that operation we will see. So now this operation is transforming records into key value pairs. Pairs means here tuples here. The pair should be a tuple object. Then only you can perform grouping aggregation into the Spark. Okay, how to perform grouping aggregation, that we will see into the Spark. Now how to transform the things into key value pairs we will see now. Okay, your data is this one. Totally you have 4 elements here. I am going to transform it. Val some pairs is equal to pair 1 is equals to emp.map. I am using curly bracket means going to perform multiple statements. As usual, first step I am dividing that into array. Val w is equal to x dot split. Delimiter is comma. Next I am going to separate this x value. Here sex is in fourth. Fourth means index number 3. And salary w of 2. But salary is second index, okay, but we need it as an integer, because next we are going to perform aggregation on this one. That's why dot to int. And returning a tuple, val some t is equals to, it should be as a tuple key and value. The first one is key, second one is value. So here key I am giving sex, the value is salary. But if I close it, nothing will be written, because everything is as assignment here. That's why as a last expression I am giving t. Okay. Now observe the output. Each element is transformed as key value tuples. If data is like this, this is eligible for your Spark aggregations. Okay. So in this way you can convert them into key value tuples. Okay. Same style, I am going to write one more query. For this, how should be the key value pair tuples? You just tell me. Now my query is like this. Select a department number and sum of salary from table name. Table is EMP. Group by department number. For this query, I am going to write the key value pairs. Already have EMP. Come on, try it. Val pair 2 is equals to emp.map. Here x is each record string. Val w is equals to x dot split. This time we need to separate this department number. Department number is in 5th position, that means index number is 4. And salary x of 2, and make it as integer to int. And finally you are returning a tuple expression. So tuple is enclosed by open brackets, right? DNO comma sal. Automatically DNO will become key, sal will become value. Now check the output. This is, of course, here some mistake is done here.
It's W of 4, I think.
Yeah, we said x, right? W of 4. First split W of 4. Then salary. Then you are returning key value pair. Okay, now department number is key and salary as value, but still we are taking this department number as a string only, because we are not going to perform any operation over here.
Salary also W of 2.
Salary W of 2. Then we forget that one. Yeah. W. Then the key value pair. Yeah. Now it is correct. The key is string here, the value is integer. Okay, it's all like simple aggregations. And one more thing, suppose this time my query is like this. Select a department number, comma sex, then sum of salary from EMP. Group by department number and sex. Just a minute. Yeah. Observe this here, grouping by multiple columns. But if it is pair, means always pair should be key value. Key should be only one. Okay, in that case, how to transform is array. Suppose first record is 11 and sex is M, comma salary. Suppose salary is 20,000. Now this entire thing is one pair. Observe this. Here in the place of a key, a tuple is acting as a key. The tuple contains both the department number and sex value. Because the key should not be two. That's why like we have placed one single object, that is tuple. The tuple is department number and sex combination. Suppose second record is 12 department, which is female. Now this entire thing is a tuple. The tuple should be placed as a key. Suppose the value is 30,000 salary. In this way we need to transform the things. Okay. Now how to transform such kind of things we will see. This time I am taking pair 3, emp dot map of array x dot split. First, as usual, separate all the required things first. Department, which is 4th index, and sex which is third index, and salary, second index, but as integer. You have three things, but key should be only one. That's why you are constructing your own key. Suppose my key, val my key is equals to a tuple of dno and sex. That's it. Now you are going to prepare a tuple. Val tuple is equals to my key as key, the salary as value. Now you are returning this tuple. Now check the output finally. So in the place of a key, a tuple is existed. A tuple is presented here, right? In this way, whenever you want to perform multi-grouping data, the pair should be like this. The key should be as a tuple, so that multiple grouping aggregations you can perform. So these are the simple transformations what you can do. Next, making records into structures. Here we have two techniques. One is tuple, second one is case classes. So what is case class? First we see that a tuple, later we jump into that case classes. Then what is the importance you can understand. See, tuple means, is a collection of elements, collection of heterogeneous elements. Generally, record is having like different heterogeneous values like name, age, city. In this way, different data types and different field entities will be there. For maintaining such kind of structures, the tuple is helpful. Now look at this emp dot for each of println. Each element is a record here in the format of string, which is delimited by the comma. Now entire record I want to convert into a tuple object. Okay. See, observe this. Val sum records is equals to. I'm going to transform this entire emp into the tuple chain. Emp dot map of. As usual, first you are splitting and separate all the fields. First ID, which is 0 index, converting into integer. Name, first index. Salary, second index, but I want it as integer. Which is fourth index now. Sorry, third index. Department number, which is fourth index, converting into integer. You want to perform any conditional transformations or you want to generate a new fields, you can generate here, same as your previous classes. Finally, I am going to return a tuple. The tuple should contain like 5 fields here. The first is ID, name, salary, sex, department number. Like this. Now check each one. Records dot for each of println. Now each record is transformed as a tuple. If it is tuple, okay, each tuple has like each tuple is having multiple elements. Each element is of different data types and different purposes. So how to access tuple elements? Suppose in front of you, in your hands, if there is a tuple, how to convert that? How to convert? Like how to convert your tuple objects, tuple elements into key value pairs. Suppose same, I want like sex as key, salary as value as a tuple. If your input is a tuple elements, okay, then how to transform it? One example we will see. Suppose pair 4 I am taking. Input is not your original string data. Input is this tuple data, array of tuples. Map. Here x is each element. I want to return a tuple, that's it. In this example, sex as key. If x is tuple, how to access x is x dot underscore 1. That's it. Sorry. If it is sex, the position is 4, right? X dot underscore 4. Don't say index numbers here. In tuple, by using position numbers, you are accessing the data. Same thing salary. Salary is in third one. X dot underscore 3. And again, I am going to convert into integer. X dot underscore 3 dot to int. Now each element is converted as key value pairs. Sex as key, salary as value. In this way. Suppose my question is this one. Input is same, still tuples. I want this one. From Rex. This is what my query. So for this query, so first what to do? Observe this operation. Well, I'm going to separate only salaries. Input is records. That means from each tuple we need to extract only the salary. X dot underscore salary means 3, but no need to convert into integer because in the tuple already salary is integer. Now up to now what is the output? Only salary is extracted, right? So now directly you can say dot sum. Check it. Directly the total salary you will get it. 30 plus 50 plus 60 and 80. So in this way, like each tuple is having mixed elements with mixed data types. Whatever the field you want, by using that position number you can access it later. Whatever the operation you want, you can perform on the collection. So these are all like different transformations. Okay. Now by using filter we perform some transformations. We take within the single operation we take help of transformation at the same time filter. Okay. So what we are going to do first, as initial example, only filter I will apply. Later we try to club both the things. Suppose there is a text data. The text data is like this. After that again some spaces. This is the case. Now I want to transform this data. I want to convert this data into just 3 words separated with single spaces. Here observe word 1 and word 2. Between them many number of spaces are there. Again between the second word and third word there are so many other spaces. After the third word there are unnecessary spaces again. We don't want those spaces. Okay. So what to do? First, a simple technique, remove unnecessary spaces from both left sides and right sides. Okay. Val some text is equals to text data dot trim. Now left and right spaces were eliminated, but in between the words still multiple spaces are there. We want to remove them. A normal technique, first we are going to split it. Val w is equals to text dot split. Observe in between I and love there are 4 blank spaces here, but we don't want those blank spaces. We have to eliminate them. If some elements you want to eliminate means you need to apply filter. Observe one more thing, val words is equals to w dot filter I am applying. X is each word here, each element. We don't want blank spaces. That means your condition is X not equals to that blank space. Now check the words. All blank spaces were eliminated here because of this condition. Now this is not our expected output. We are expecting complete a string. This collection has to be transformed into a string. In between each word we need a single space only. Now val string is equal to, or else like a new line is equals to, val new line is equals to. Now words dot, you have a function called mk string which will convert your list or array into a single string. Automatic concatenation will happen. Suppose if I say like this, observe this, a blank space I am giving. Between the words there is no space. If you need a single space means give single space here. Automatically that will be concatenated with single space. Previous your text data is like this. Many number of spaces between the words. Now you are transforming it as single string. Because especially while dealing with unstructured data, okay, we generally we extract the data from the different tweets from the Twitter or Facebook like that. So generally user, that is user wish, user will not follow different grammar rules. In his own style he will type. Some users will give multiple spaces between them. Okay, but before applying your unstructured data processing and applying your sentiment analysis over that, first data should be cleaned. Within that cleaning process, as a first initial step, you are transforming, that means you are removing unnecessary spaces like this, okay, by using this technique. Now in this example, the text data is a single element, a single sentence. But if you take a tweet, the tweet is having different statements, right? And multiple statements will be there. At the time how to proceed with that we will see. Now I am taking val a comment of one particular user. Let's check like this. Val comment is a list of different comments, different sentences. Suppose first sentence is like this. After that so many spaces, spark, again spaces. And second one, Hadoop, you love Hadoop. And next one, Hadoop and Spark are great big data processing systems. Okay, simply three sentences I am taking. Now each and every sentence I want to adjust into a still sentence, but I don't want multiple spaces between the words. On that way we need to transform them. Okay. So here we are going to take help of all the things. Within the map again we are going to apply the filters. Just check how to deal this. Well, some result is equals to, or else like a new comment is equals to. Input is comment dot the transformation you are starting. Here line I am taking. Now each element is a line. My first step going to remove the spaces and then split them into words. Val w is equals to line dot trim. For this apply the split. For splitting the delimiter is white space. That means single space here. Now what the w is a array now. But between you and love, different blank elements will be there. We don't want those blank elements. So that how to eliminate the blank elements? By using filter. Val words is equals to w dot filter. What you don't want blank spaces. So that your condition is x not equals to blank space. So now all blank elements are eliminated. That means the empty spaces are eliminated. Now I am going to construct a string. The words dot mk string is our function. Between each word I want just only single space. Now this thing finally we are written. In this way, within the map you can apply the filter. Okay. Now check the output. Finally, new comment dot for each of println. Each element we are printing now, like this. Previously a lot of other spaces, now only a single space between each and every word. So more unstructured data examples we will see when we enter into the Spark. This is just a basic preparation. In this way, so many cases we have to use the transformations. Okay. Yeah. So previous example, what we have seen is how to make records into the structure by using tuple techniques. Okay. Now, what is the problem with this tuple? If you observe this, the tuple shape is like this. Some 101, letter something, after that salary, then sex, then department number, like this. Now in this case, it is having just only 5 records. Okay, easily you can remember the positions and everything. Think that if the like record is having like hundreds of fields, at the time definitely like we cannot remember the field positions at each time. Okay. So the problem by using tuples, you can make the data structures, you can make the data into structures. But problem with them is this tuple is not having schema. Suppose if it is a SQL table, how you are accessing the data, you are not worrying about the positions of the columns. Suppose you need salary, directly you are saying select salary. Suppose you need the name and city, select name comma city, you are saying. Automatically the required fields will be extracted. So how it is possible? Because the table is having schema. But here the tuple is not having schema. You need to remember the positions. Based on the positions, you need to access them. Similar to SQL tables, I want to provide schema to my data objects. Now for this purpose, the case class is available here. Okay. Let's look at a simple case class. Case class. The class name I am giving Sam. And here I will give some structure for this. As initial example, only 2 fields I will take. Only 2 attributes. A int, B int. That's it. Only 2 things. Okay, let's take C also. C int. 3 things. Each and every one is as integer. You can give different data types also. Suppose name string, salary int, city string, like that you can say. Okay, first example, let's see like this. Case class SAMP. Now SAMP is created. Now you are creating one object. Now this SAMP can act as your custom data type, your own data type. Okay, val s1 is equal to, I am saying that 10, 20, 30. Now here in this example, this 10 is for A, this 20 is for B, this 30 is for C, like this. On which order you define the values, on the same order the values will be assigned. One-to-one mapping. Okay. Now the second one, val s2 is equals to, is a SAMP of 1, 2, 3. Val s3 is equals to a SAMP of 100, 200, 300. These are the simple objects, simple case objects. See, if it is array, you are accessing the elements, array as list or list, you are accessing elements by using index numbers. If it is tuple, by using position numbers. If it is key value pair, map collection, if it is map collection, by if you pass the key, automatically you are getting the value. Similar to that, if it is SAMP class, if you give by using the attribute names, that means field names, you can access the data. Suppose I want a value. I want a value from the S1. Okay. It doesn't matter for you what is the position of the A. Okay. Once you know the schema, simply S1 dot A automatically will get 10. S1 dot B 20. S1 dot C 30, like this. In this way, by using column names, that means attribute names, you can access the elements. Okay. Now I am going to make all these things as a collection. Val some list is equal to, or like S is equals to. S is a list of S1, comma S2, comma S3. Okay, now just observe. Each element is what here? Each element is a SAMP object here, right? Okay. Now a simple transformation I am expecting from you. What is the total for each element? What is the total for each element? Suppose from the first element I am expecting the result 60. From the second element 6. From the third element 600 I am expecting. Just one simple process we will do. Val sum result is equals to S dot map. Now X arrow. Here X is each SAMP object. And you are saying that S1 plus still S1 plus S1. Now you tell me I want first element. How to access the first element? S1 dot A. Second element S1 dot B. The third element S1 dot C. Now a single value returned from each SAMP object. You will get the total now. Now you check it. S1, S2, S3. Some wrong answer is just appeared. What happened? Just to try to scrutinize this. Yeah. Let's say X dot A, not S1, because each element we assigned it as X, right? X dot A, X dot B plus X dot C. This is correct. Now we check from the first, that is 60, from the second, that is 6, and from the third, okay, that is 600, like this. Okay, in this way, by using field names, you can access it. Now, previous example is very rough example. Now, let's try to transform our employee record into EMP case object. Okay. Now, what is our employee record? That is this one. Totally 4 records you have. Once again, with the line by line, we will print it. For each of println. Totally 4 records. Each record I want to convert into case class. So that's why first I am creating a case class. Case class, the class name is EMP. Totally 5 fields I will generate. ID as integer, name, string, salary, int, sex, string, and last field department number. Okay, only last field I don't want department number, I want a department name. That means before converting them we need to perform a transformation. I want department name. Only one this field we will transform. Remaining already know how to perform different conditional transformations. I want this one. Come on, try to code for this. It's not. Let's open fresh notepad. Already EMP case class you have. This is EMP case class. And records already there. That records also I will copy. That employee records also. This is the data now. For this data, I want to transform into EMP. Come on, sir, all of you, please try. Val E is equals to simply E. Input is EMP. EMP dot map. X is each record. First, as usual, split it. Val W is equals to X dot split off. This one. Now array will get and separate the elements and apply required data types for them. The first what I need, first I need ID value. That's why separating that ID. Val ID is equals to W of 0 dot to int. Next one I need name. Val name is equals to W of 1. Next salary. We want it as integer. W of 2 dot to integer. Then sex, which is third one. Val of 3. But we don't want department number. First we will take the department number, later we will transform it. Val department number is equals to W of 4 dot to int. But actually what we need is, we need department name. That means conditional transformation we require now. For this val d name is equals to dno match. Already you have seen that match operation. And case 11. If it is 11, what you want? Marketing. And case 12. If it is this one, let's say HR. And case 13. Finance. What is the option for other than this 11, 12, 13? In case of Java, switch case we are using default. Here case other. If it is other, just replace it with others. That's it. Now finally the val, the d name return type will be string only, because each case is returning a string value. Okay, now you need to create your EMP object. Okay, so that's why we are taking one more expression here. Val e is equals to, but already I think this name is e. Let's go with a different name. Val EMP is equals to, or record is equals to EMP, the case class you are using now. Already case class is defined previously. First what you want? ID. Next name, salary, then sex. No department number, we need department name. And finally you are going to return this record, which is last expression. In this way the records you can convert into the case classes. Now check it now up to now. Already in our Scala part we have created this EMP case class. Now you are executing this one. Observe each element, sir, within this E. Just printing line by line, you can easily understand. E dot for each of println. Now each element is a EMP object. Okay, now in our hand you have EMP case class. From this case class I want to separate department name as key, salary as value, sir. Department name as key, salary as value. On such way I want to construct a key value pairs. Observe this, val pair 5 is equals to, your input is E this time. Forget about our original data. Directly, if you have directly the case classes, how to transform them into key value pairs. Val pair 5 is equals to E dot map. Here X is each element. Each element is a case class, which is EMP. I want a tuple. If it is tuple, I need pair, key and value. Key should be here department name. If it is department name, don't worry about the position. Okay, X dot D name, that's it. By using column names, you can access it. Same style, I want salary. X dot salary. Automatically key value pairs will be constructed. Observe, the department name as a key, salary as value. So in this way, this is the thing for each department. Okay. So in this, by using these two techniques, 1 minute. So department name as keys and salary as value. Here how we access this is a simple technique by using field names. Just like this is approach like RDBMS tables, right? Select dname comma salary, on such way you are working. So later, not only this is the advantage number one here, the case object advantage number one. You can create you can provide schema. Then what is the advantage of this schema? Based on the field names you can access it. And next advantage, later when you enter into the Spark, you have a component called Spark SQL. I want to convert my RDD into a table means, first of all, I need to provide schema for that. If your RDD is having schema, then you can convert that into data frame. Later the data frame will be registered as tables. Without schema, that is not possible. Okay, these case classes exactly will be used in our Spark when we enter into Spark SQL. Okay, but this case class has some limitations. What exactly that limitations in the Spark part we will discuss. Okay, so up to now, any questions, all of you? So please switch on for 2 minutes. No questions? Madhuri, any questions? Srinivas, Vinay?
Sir?
Yeah.
No, sir.
Okay. Okay, sir. This is a style like all these are the different workings. But now we are just purely on local objects we are working all these operations. Later we need to work all these operations on RDDs. Now you are doing these transformations on local objects. But what are Spark objects? Spark data objects are called like RDDs, right? We need to perform all these operations onto RDDs. Okay. Now we see today how to create our functions. Up to now we are using like predefined function. If any case required to develop your own custom function, how to develop that for custom function. So that operation we will see now. Yeah. First, how will be the function definition? First, all of you consider here. Define is the keyword to create your function. Suppose my function name is just f. Okay. After that I am saying colon. The return type I am expecting is a string. Right. And the value I am giving hello. Just observe this format. Whenever I call this f, I will get, sorry, just say f, I will get hello. This is my function. Once again, f is the function name. This function return type is string and you are assigning some value, and whenever you call this, you will get hello. But generally function has to receive some arguments, right? Here there is no bracket definition I have given. No bracket here. That means this function is not expecting any value here. Simply if you say f, you will get hello. One more operation, try to understand this. Same function I am giving. Define f. I am not saying colon and return type. Just equal to hello I am saying. Now what is this? You did not say any return type here. Previously you said return type, but in this example you did not say any return type. Automatically the hello will be returned. That means the return type will be automatically constructed. Right. Okay. Now if you say f, you will get hello. Okay. One more small operation I want to show you. define f. Still I am not saying any return type. Automatically return type will be constructed. I am going to say like this. The first hello, the next one hi, the next one let's say bye, and I am closing this. See here, one more small change. Let's close this. Now small modification, hello and hi, closing this. Now observe this. I think one semicolon we will try and we will get. Yeah, we forget again. Without expression directly, without assignments directly expressions I am giving. I am trying with that. No, it is not accepting multiple expressions. Let's use the assignments here. Define f. Val x is equals to hello. Val y is equals to x dot 2 uppercase. And finally saying that y. Now observe this. There are multiple statements here. Because of multiple statements in this function code, okay, you are using curly brackets, same as your previous transformation techniques. Okay. Now what you are expecting by this same hello, you are expecting into the uppercase. Whenever I call this f, what is the last expression here? Y. The y will be written. The y is hello into the uppercase. In the first two examples and in this example, we are not passing any argument to this one. Now one more simple function I want to show you. The function has to accept user arguments. That means it has to accept the arguments, and based on our code, the operation have to be done. Now check it now. Define. The function name is fx1. Now this time it is going to, or let's say simply fx. The function name is fx. Here I am giving bracket means some argument is going to expect. The argument I am saying a value as int. That means one integer value you are going to receive. Return type is still int, but return type is not required. Automatically based on the given expression, return type will be constructed. As a first initial example, we use that return type is equals to simple expression, one single expression you want to give, no need of curly brackets. I am saying simply 100. Now check it. What is the meaning of this one? This line here, fx is the function name, a is the argument type is integer, the return type is integer here. Now just say fx here. No, it won't allow you because it is expecting some argument. Now just observe fx of 100. What is expected output? The expected output is 100 plus 100, which is 200. That is. But whenever you want to give multiple statements, you keep the same statements into, okay, keep the same statements into curly brackets. That means blocking technique. Okay. Now one more example we will see. EMP. I want to convert this into EMP case. I want to develop a function. Previously directly you have given some piece of the statements into, okay, your map transformation. Because if this operation is regularly required, every time instead of writing all those statements into the map function, create one function first. Next onwards, whenever that transformation required, you can call this function. Okay, this is simply the code reusability. Okay, now same I am going to convert this record into a case class. So already have case class. Okay, just to recall it, once again I am creating this case class. Case class. The case class name is emp. ID int name string salary int department number sex string department number int. And still I need a few more things. I want new name. Okay, let's use that name. That name as usual, first character uppercase, remaining characters lowercase. Already we did that transformation. For that purpose we write a function now. Whatever the regular transformation required for you, keep that transformation as a separate function, so that in all our next operations you can call that one. Okay, and I want department name string and a grade also string. These are the operations we need. These are the fields we need into the EMP class. Okay, just remember this order and the new fields what you want. Let's start our work from here. This is our case class. And already have data which is EMP. I want a function now. The function has to convert first letter into uppercase, remaining characters into lowercase. Okay, I want to define a function for this. Next onwards, directly we need to call that one. Wherever you require that, you can call it. The function name is define first upper. This is the function name for first upper. It is expecting one argument. The argument is a string. That's why x colon string I am saying. Return type automatically will be the string. No need to give it. But as a formality I am giving. And I am going to give the statements. Now forget about the list and collection. Look at only this x. This x is a string. Our target is first character uppercase, remaining characters lowercase. Previously we applied this into the transformations. Do the same statements over here. Val fc is equals to fc, where fc is a first character. X dot slice 0, 1 dot to uppercase. But better practice, val the word is equals to x dot trim. Any left and right spaces are there, that will be removed. Let's say w. Here w dot slice. Next, extract all the remaining characters. Second one hours all remaining characters. RC is equals to w dot slice of 1, w dot size. Okay, w dot size. Just check the size. Size function is available only for the list, and I think it's available for abc dot size. No need to apply the length. Okay, abc dot length also valid. You can say both the things. Okay, yeah, same thing I am applying. A dot size. The remaining characters you are converting into lowercase. And finally, the name is equals to val name is equals to fc plus rc. First character and remaining characters you are concatenating now. And finally you are returning that name. Okay. First we check only this function. Only this function we are going to check it. Okay, the function is this one, function defined. So expecting string argument, returning string argument. Observe this one, my function is first upper of H capital E LL capital O. Now expected functionality by this H into capital remaining all the things into lower. Just check it now. Converted, right? Yeah. Later we will use this into our transformation. This is function number 1. And one more function I am going to write. This function is for not salary. Let's transform our sex. Define like function name is simply MF I am saying, or gender. Previously our values are M and F. Let's make male and female. Still the argument is string. Return type is also string. Remember that return type is not mandatory. And you check the condition. If sex is equals to M, but value can be uppercase or lowercase, right? That's why sex dot to uppercase is equals to. Use capital M. Then you are saying that you are returning male, else female. This is our last expression. So this expression will return either male or female only. That too, this is our last statement. Now you just check it now. The function name is gender. Executing this. Sorry, here X we said, not sex. Let's modify. The variable is X. Now checking the same thing. Now you are testing. Gender of small m I am giving. What is expected? Male. Okay, let's try with capital M. Still male. Try with F. Now you need female. Like this. Okay, second function is also ready. And one more function. The function we will write for grade. If I pass salary, I am expecting the grade value like A, B, C, D, E. Okay, for that purpose we will write one function. Define grade. Now what is your argument? Argument is integer because you are going to pass salary, but return type is string because A, B, C, D, on such way you need grades. Equals to. So better like already you have nested if, and also you can use case class. Sorry, not case class, match, which is equivalent to switch case. Okay, now I am trying with this nested ifs. If X greater than or equals to 70,000. Let's say grade A will be written. Suppose if it is else, you are checking with one more condition. If X greater than or equals to 50,000. Okay, let's do this one. Then grade B. Still if X is greater than or equals to 30,000, you need a C grade, else D. These are the values you are writing, but the A, B, C, these are the strings, right? Let's keep them into quotes. This is A grade, it's B grade, greater than or equals to C, D grade, it is for D. So this is the simple expression we have given. Now let's validate this. The same problem, at brackets this is missed. Just a minute. Grade x colon int string. If x is greater than or equals to 70, then A, else then B. Don't say B in the place of F, else. If x greater than or equals to 50, here actually the problem, let's say B, else C. And finally I am closing. Let's continue the same statement. Else, again one more if we are giving. X greater than or equals to 30. Then we need C, else D. Yeah, now closing this one. This is a simple statement. If you are coming into the next one, try to use the brackets, because already you have seen this kind of problem into the previous transformation, your last class transformation. Because here I have given everything as a single line statement. That's why no need of any say brackets. Suppose if you are coming to the next line, suppose if some condition A you said, and then you want to come to the next line, means if you say enter, it treats that the statement is completed. That's why in the next line, if you write this else, without if else statement is applied on such a way, the compiler will treat it is showing you as error. That's why you are writing as this one. Okay. So that's why whenever you want to come to the next line, try to give the brackets, right? Okay, now grade. Let's pass some value. I'm passing 80,000. We are expecting grade A. Passing some 55,000. Grade B we are expecting. And 35. Grade C. Below 30, 25. Grade D. Okay, behaving perfectly. So this statement we will use it here. Same statement. Yeah.
Before C, keep else.
Hmm?
Near
Oh,
greater than or equal to 30,000, keep else.
after C else.
Before else, if you
Be-
kept only if, sir.
That
So
madam,
else.
before else C, after else D.
No, sir. Actually, after B, else if it should be, you gave only if.
This one, okay, okay.
Uh,
Yeah, right. This. Okay, same statement here. Yeah. Still anything pending? One more transformation is pending, I think. Let's go with the department names also. Define DEPT, the function name. Still int I am passing because department number. Data type string. Okay, int. Return type is string. DNO. Suppose val dname is equals to DNO of match. Case 11. Marketing. Case 12. HR. Case 13. Finance. And case others. Finally returning is DNA. Now check this. Yeah, here small mistake. After case others, we need to close this match function. Just modify this. After others, close this bracket. Here
X,
X.
X.
And ikkade marchadam. DNO. Okay, sir. Now test it. DEPT. Let's say like 15. What is expected? Others. 12 HR. 11 marketing. 13 finance. Okay. Now all functions ready, which are used for your transformation. And finally, I want a class. I want a function which returns a case class. I am expecting this object finally. Okay. This object I am expecting. Now within the from one function we are going to call one more function. Now I am going to write one more function now. Just check it now. Define 2emp. My case class name is 2emp. My function name is 2emp. Argument is a line. That means entire employee record you are giving as a input. Line as string. Return type is emp. Emp is a case class. Okay. Return type emp. Of course, return type is not mandatory. Come on. First I am separating. Val w is equals to line dot split. What you are expecting? First ID as integer. Val ID is equal to w of 0 dot to int. Next, name. But name, what I am expecting in the name? First character uppercase, remaining character lowercase, right? For this purpose already have function, right? The function name is first upper. Okay. I am calling that one first upper of w of 1. W of 1 is a name value, which is second position. For that, first upper function is applied. Automatically, the name is first character uppercase, remaining things lowercase. Now, within this 2emp, you are calling one more function. Okay? Like this. Next one, salary. As usual, W of 2, but I need it as integer. 2 int. After salary, what we want in the case class? Sex. But direct values we don't want. We need M as male, F as female. That's why. For this already we have the function called gend. Gend of W of 3. Okay. One more function we called it. Next, Department number. We need department number, then department name, and then grade. Next department number I am giving. Val department number. W of 4 to int. Next department name. For this department name, your previous function is a DEPT. I am calling this one. DEPT. DEPT of DNO. Not DNO. DNO already separated, just DNO. Yeah. Next grade. Val grade is equals to. For the grade, what is the function name? We said grade only. Grade of. The value is input is salary. Now you just check it up to now. But we need a case class, right? EMP is equals to first ID EMP of value is equals to EMP of first ID, name, salary, sex, department number, department name, grade. So all the required transformations we are making. Finally, you are going to return E. Up to now, just check it. Already we executed all the previous functions. Now directly we are going to call this to EMP function. EMP case class is not executed in our Scala shell. Okay, first I am executing this EMP case class. Okay, now EMP is having total how many fields? 1, 2, 3, 4, 5, 6, 7 fields are there. Let's execute the previous function now.
Before is braces required, sir.
Yeah, previously already we have one EMP, right? That is a mistake. Let's change the name. EMP1 or let's say EMPL. Here also EMPL. Here we need to say EMPL. Already this is modified. Once again I am executing this. Finally, let's return EMPL. Yeah, EMPL. Grade of salary. Again, val grade is equal to, again, function name itself is a grade. We will change that name also. Here, let's say ZRD. Here I am returning ZRD. Because function name and variable name both are same now. Okay. Now test it. Let's pass only 5 fields values based on the same previous structure. Once it is done successful, then we can apply into the transformation. The function name is 2EMP. Passing a record structure, suppose 201 Amar name salary 80,000, is a male, and department level. Now check it. 201 Amar 80,000, M is transformed as MALE, and department 11 means marketing. The grade is grade of employee is A. In this way, directly we are going to apply this function into our transformation. Okay, now just check it. Records. Okay, this is your, okay, this is tuple. Take this EMP. Each record I want to transform into case class, but I already, to convert this into case class, already some existed function is there. I want to use that function. Okay, now val, let's say EMPS is equals to EMP dot map of to EMP. Your function name is to EMP. Input is just X. That's it. No need to give the remaining statements. Already all required statements applied in our previous function. Automatically each record is converted into uppercase. Sorry, employee case class. Now just check each and every value. EMPS dot for each of println. Okay. Now each one is converted as case class, right? So in this way you can take help of these functions. Right, sir. One simple thing we will try. I want to write a function which returns a boolean value. Later how to use them, how to use those boolean values into your filters. Okay. All of you observe this. I define the function is male. One simple, very simple function, is male. Argument is string, but return type is not string. Return type is boolean, I am saying. Of course, return type is not mandatory. Okay. X dot to uppercase, because your passed value can be lowercase value or uppercase value. That's why everything I am converting into uppercase. If X dot to uppercase equals to M. Okay, only this one. Right. Observe, I'm testing this one. Is male of, I'm saying that small m. What will be the return type? What is the return value now? True or false? True. Capital M, I'm saying true. Other than this M, let's say F, false. Okay. So this is simple function. I want to apply this into filters. Right. Okay, let's take this one. Val LST is equals to. Think that first one is male. Is a list of male, male, female, once again female, male, female, and male. Okay, in this way different elements I have. Come on, I want to take only males. Already have a function called is male. Come on, all of you please try. Please switch on and please tell me, sir. Already have function, is male function you have. Suppose if I say is male of some value, suppose M I am saying, if by M is passed it will get true. I want to take only male values. What is the filter function now? Val result is equal to, or else like say val males is equals to. Come on, I want to take only males. List dot filter. Come on, sir, you proceed. I'm stopping.
X.
సార్ ఇక్కడ ఉండటానికి 16 మంది ఉన్నారు, ఒక్కరన్నా నోరిప్పండి. స్విచ్ ఆన్ చేయండి మైక్స్. ఆన్సర్ చెప్పండి ప్లీజ్. ఇప్పుడు మైక్స్ ఆన్ కాకపోతే అందరినీ టెర్మినేట్ చేస్తాను సార్, కనెక్షన్స్ అన్ని డిస్కనెక్ట్ చేస్తాను ఇప్పుడు. నెంబర్ 1 హేమ డిస్కనెక్టెడ్, మాధురి డిస్కనెక్టెడ్, చెప్పండి. ఆల్రెడీ వి ఫస్ట్ ఈచ్ ఎలిమెంట్
Yeah.
ఈజ్ మేల్ ఆఫ్.
Is male. X is male of X.
ఓకేనా? సేమ్ స్టైల్ సార్. I don't want to develop one more function. By using the same function I want to extract females. Come on please.
Val females equal to
First check the values. Val this time females is equal to females is
females
equals
equal
to
to
lst dot filter.
filter of X equal to not of
Yes. First మనం ఇచ్చేసేది negation.
is male
Male. That's it.
Male.
Simple technique. Is male of
of X. X.
X. అంతే. So if M is passed, it will not return because you are applied negation, right? Now only females will get. This technique apply for this one, sir. Now this is your EMP. Come on, all of you. Once again, I am showing you this data. EMP dot for each.
EMP for each of
ఒక్క నిమిషం అంటే అవుట్పుట్ చూసిన తర్వాత చెప్పండి. Now come on, proceed. Each element is a string now. I want to take only males. Val M is equal to MC is equals to
MC is equal to
EMP dot
filter
filter.
of X. X is male of X not
Except 3 dot is male.
X dot. Sir, only how to take this male value, sir.
is
Just a
male of
simple
X dot
expression. Is male of X dot split,
split
comma. How to take the fourth one? Index number 3.
index 3.
Okay? And close the bracket. And this is the closing bracket for this one. Now you take this. Only males, right? So first one 101 male and 103 is also female. Same thing, you don't want males, you want only female list means apply is male. Okay? Negation. Now you will get only the female data. In this way, conditions also the you can develop a that functions for even which returns Boolean values. Okay. Now last trial, sir. I have EMPL. What is your previous data? R result? Previously we applied transformation. We converted that into case class. EMPS, sir. Now look at this EMPS. EMPS dot for each of println. This is not a direct string record. This is a EMP case class. Now I want to take only males. Of course, previous function is validating only either M character or F character. Now my data is like this. I want to take only males data. I don't want to write one more function. Previous function help, I want to take it. Come on, result is equals to Result is equals to
L2 MPS
EMPS dot filter. X is each case class now. How to take only sex value, sir? How to take only sex value, sir? I want only this
Position.
index number or
EMPS
column name?
column.
Index number or
Yeah,
column
with
name?
a column.
Column name, right? X dot
Column.
sex. Okay. If you apply dot slice for this, what is the value of x dot sex, sir, for the first row? Only MALE, right? How to
Yes,
take
yes,
only
please.
first character?
0,1
0,
0, 1.
1
Okay. So
is
for this, if we apply this function, is Melo.
Melo.
What you will get, only male data or not? Now check this result dot for each of println, right? Only males. If you say negation, you will get only females, like this. Clear, sir? How to develop function and designing case classes and making data into structures by using two techniques. One is tuples and second one is case classes. So full-fledged advantage of this case class you will see in our next Spark sessions. Okay. And still one more session I will take on this one. Okay. If necessary, day after tomorrow also I will continue with maximum. I will try to complete the concepts by tomorrow. If anything pending as per my document, let's verify tomorrow. Okay. And max to max by Thursday we are going to enter into Spark. Okay. Right, sir. And all of you go through all these videos. And before I go to the Spark, you need to commit for one examination for this Scala and Spark architecture. Okay. Yeah. Okay, sir. I'm going to stop this recording. Next,
Okay. So this is Pawan.
yeah, Pawan Chapana.
Yeah.
This thing we will see how to pass the multiple arguments. Same style. Observe this.
Okay.
Suppose total is my function. Okay. X int, Y int. Return time I'm expecting still same thing. Int. Let's say colon here. Simply x plus y is my result. Of course, only one expression, no need of curly brackets, right? X plus y. I want to return. I'm going to call it x total comma 100 comma 200. What is expected? 300. Return, right? In this way, you can pass multiple arguments also. Okay, tomorrow, like still in function, one part is pending, like a recursive function. So how to use that recursive function? One or two examples we'll see on recursive functions. Later we'll verify our document if any conceptual things missed, or not conceptually all the things as per the document I covered, and any examples which are not available here, we go for different examples. In the document I went for different examples again. If any new example appeared, like we will verify. Okay. And any questions you discuss with me tomorrow. And later, sir, once like we enter into the Spark core coding, once the Spark core coding completed, I will show you with the SBT operations, how to write all these things into the Eclipse by using Mavens and SBT. So because up to now, like we are executing into that REPL shell, interactive shell. Okay. So if I want to write a program similar to like Java, okay, then how to write it, how to submit the thing. Once Spark core completed, I will show you this one. Okay, sir, all of you. Thanks for the day.
Hello, sir.
Yeah, tell me.
Second, sir. Sorry. But
Chapan, sir.
hello.
Hello.